Dear students, in the last class we learnt about the conformation of cyclopentane. Here N is equal to 5, that is C5H10. The bond angle is 108 degree, that should be nearly equal to tetrahedral bond angle, that is 109.5 degree. Here there are three conformations are present. First one is planar. Planar means all the atoms should be present in the same plane. Then envelope. Envelope means 4 carbon atoms in the same plane and 1 in the out of the plane. It means endo. Endo means inside the molecule. This have a less energy and this conformation is a most stable. Next, third one is half chair. Half chair means 3 carbon atoms should be present in one plane and other 3 carbon atoms should be present in the another plane. Okay, this is all about the conformation of cyclopentane. Next is conformation of cyclohexane. Here cyclohexane avoids a torsional strain. Torsional strain means repulsion between the 2 electrons present in the adjacent 2 atoms by adopting non-planar conformation, which also reduces the bond angle to the tetrahedral angle. In that the cyclohexane have a greater than tetrahedral angle, so that's why this cyclohexane adopting a non-planar conformation that reduces the bond angle. Okay, this is the carbon-carbon single bond. Okay, the chair conformation of cyclohexane, it is most stable, it has no torsional strain, the bond angle is very close to ideal value, it is 109.5 degree. This is the structure of chair conformation of cyclohexane. And in the cyclohexane they have a 2 bonds, different bonds are there, axial and equatorial bonds at the chair form, 6 bonds for axial and 6 bonds for equatorial. Axial bond means they are parallel to each other. Here this will be the axial bonds. Here you have to see, here there will be 3 bonds in the facing up and 3 bonds will be facing down. This is the axial. ಇದರಲ್ಲಿ ನೀವು ಕರೆಕ್ಟಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಇದರಲ್ಲಿ ಫಸ್ಟ್ ಒನ್ ಈ ಕಡೆ ತುದಿ ಮೇಲ್ಗಡೆ ಇದ್ದರೆ ಈ ಕಡೆ 2 ಕೆಳಗಡೆ ಇರುತ್ತೆ, ನೆಕ್ಸ್ಟ್ 2 ಮೇಲ್ಗಡೆ ಇರುತ್ತೆ, ಇದು ಕೆಳಗಡೆ ಇರುತ್ತೆ. ದಿಸ್ ಇಸ್ ಆಕ್ಸಿಯಲ್. ಇನ್ನು ಮಿಕ್ಕಿದ್ದೆಲ್ಲ ಈಕ್ವಟೋರಿಯಲ್. ಓಕೆ, this is the how the axial and equatorial hydrogen atom should be differentiate. Okay, next will be the boat conformation. Next is boat conformation. In that boat conformation, here in the boat conformation it has no angular strain, it has no angular strain. Okay, then in addition to the torsional strain, it has torsional strain. Okay, it has torsional strain. Torsional strain means the repulsion between the 2 electrons in the 2 adjacent atoms, and it has flag pole interaction. It has a flag pole interaction between the hydrogen atoms. Okay, between the hydrogen atoms. It means which hydrogen atoms is 1 and 4 carbon atoms. Okay, in the interaction between the first carbon atom and the 4th carbon atom, that should be attached by hydrogen atoms. That hydrogen atoms is flag pole interaction. Flag pole interaction means there will be repulsion. It means it has a torsional strain, so repulsion is taking place between the 2 adjacent atoms. So the boat conformation of Here I am writing, that is very small space, so that's why it is very difficult to write there. Here I am writing this is the boat form. Here 1 2 3 4 5 6. This is the boat form of cyclohexane. Here this will be the hydrogen atom, and here there are hydrogen atoms should be present in each side. Okay, this will be the flag pole interaction. This is the first, the carbon atom should contain, first carbon atom containing hydrogen atom, that hydrogen atom is interact with the fourth carbon atom of hydrogen atom. Okay, ಅಂತಂದರೆ ಫ್ಲಾಗ್ ಪೋಲ್ ಇಂಟರಾಕ್ಷನ್ ಅಂತಂದರೆ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ಮಧ್ಯ ರಿಪಲ್ಷನ್ ಆಗುತ್ತೆ. ಇಟ್ ಮೀನ್ಸ್ ಟಾರ್ಷನಲ್ ಸ್ಟ್ರೈನ್ ವಿಲ್ ಬಿ ಟೇಕಿಂಗ್ ಪ್ಲೇಸ್. ಇನ್ ದಟ್ there will be one hydrogen atom and another hydrogen atom. ಅಂತಂದರೆ ಇಲ್ಲಿ C1 ಕಾರ್ಬನ್ ಆಟಮಲ್ಲಿರುವಂಥ ಹೈಡ್ರೋಜನ್ ಆಟಮು, C4 ಕಾರ್ಬನ್ ಆಟಮಲ್ಲಿರುವಂಥ ಹೈಡ್ರೋಜನ್ ಆಟಮು ಫ್ಲಾಗ್ ಪೋಲ್ ಇಂಟರಾಕ್ಷನ್ ಆಗುತ್ತೆ. ಆಯಿತಾ, ಈ ರೀತಿ ಇಂಟರಾಕ್ಷನ್ ಆಗಬೇಕಾದ್ರೆ ಟಾರ್ಷನಲ್ ಸ್ಟ್ರೈನ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ದ ಬೋಟ್ conformation. Here it has no angular strain, angle strain iralla, it has a torsional strain. Because of torsional strain, flag pole interaction will be taking place. Okay, and in that there will be twisted boat conformation is also present. Twisted boat conformation, compared to boat conformation, it is more stable. It is more stable than boat conformation. Okay, so and but it is less stable than, but it is less stable than chair conformation. Okay, ಟ್ವಿಸ್ಟೆಡ್ ಬೋರ್ಡ್ ಕಾನ್ಫರ್ಮೇಷನ್ ಅನ್ನುವಂಥದ್ದು ಬೋರ್ಡ್ ಕಾನ್ಫರ್ಮೇಷನ್ಗಿಂತ ಮೋರ್ ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೆ, ಬಟ್ ಲೆಸ್ ಸ್ಟೇಬಲ್ ದ್ಯಾನ್ ಚೇರ್ ಕಾನ್ಫರ್ಮೇಷನ್. ದ ಫ್ಲಾಗ್ ಪೋಲ್ ಇಂಟರಾಕ್ಷನ್ ಆ್ಯಂಡ್ torsional strain in the boat conformation are reduced in the twist conformation. Here in the twisted boat conformation, the flag pole interaction and torsional strain will be reduced. Okay, will be reduced compared to boat form. Okay, here it is more stable than boat, but it is less stable than chair. But in the flag pole and torsional strain will be reduced in the twisted boat conformation compared to boat conformation. Okay, and the structure of twisted boat conformation is, this is the structure of twisted boat conformation. Two different types should be present. Okay, and in that the order of stability of cyclohexane conformation is, chair is greater than twisted boat, it is greater than boat. Okay, this is the, and then there will be off chair is also present. It is not in your syllabus, but you have to know about that. Boat is highly stable than off chair. Okay, this is the order of stability. Chair conformation is greater than twisted boat is greater than boat is greater than off chair, and in that we can conclude that in these conformations, chair conformation of cyclohexane is most stable. This is all about the boat conformation of cyclohexane. This is the, it has no angular strain, it has a torsional strain, it has a flagpole interaction. This is the interaction, and in the twisted boat conformation is also present, but twisted boat is more stable than boat, but it is less stable than chair form, and the flagpole and torsional strain is reduced in the twisted boat. This is the structure and this is the order of stability. Okay, next we will move on to the conformation of monosubstituted cyclohexane. Next is conformation of monosubstituted cyclohexane. It means monosubstituted means one substituent group should be attached to the cyclohexane. It means it might be a CH3. Here they are giving CH3. ಒಂದು substituent group attach ಆಗುತ್ತೆ ಆಯ್ತಾ. It means in monosubstituted cyclohexane the substituent can occupy either in the axial or equatorial position. ಓಕೆ, ಇದರಲ್ಲಿ ಆಕ್ಸಿಯಲ್ ಅಥವಾ ಈಕ್ವಟೋರಿಯಲ್ ಪೊಸಿಷನ್ಗೆ ಆಕ್ಯುಪೈ ಆಗುತ್ತೆ ಅಂತ ಅಂದರೆ ಇಲ್ಲಿ ಹೇಳಿದ್ನಲ್ಲ, ಈಗ ಇವುಗಳನ್ನ ಆಕ್ಸಿಯಲ್ ಪೊಸಿಷನ್ ಅಂತ ಕರೀತಾರೆ. ಇಲ್ಲೇ ಇದೆಯಲ್ಲ, ಇಲ್ಲಿ ಆಕ್ಸಿಯಲ್ ಪೊಸಿಷನ್ಗಾದರೂ ಆಗ್ಬೋದು ಅಥವಾ ಈಕ್ವಟೋರಿಯಲ್ ಪೊಸಿಷನ್ಸ್ಗಾದರೂ ಆಗ್ಬೋದು ಆಯಿತಾ. ಅದರಲ್ಲಿ ಆಕ್ಸಿಯಲ್ ಪೊಸಿಷನ್ಗಾದರೆ ಏನಿರುತ್ತೆ, ಈಕ್ವಟೋರಿಯಲ್ ಪೊಸಿಷನ್ಗಾದರೆ ಏನಾಗುತ್ತೆ ಅಂತ ಹೇಳ್ತೀನಿ. ಹಿಯರ್ the cyclohexane should be attached to, first I am writing the methyl group should be attached to the axial position. Here this is the cyclohexane. Okay, here this is the axial position. Okay, here H is there. Okay, this is the methyl group at axial position. Okay, ಇದ್ರದ್ದು ನೇಮ್ ಬಂದು methyl cyclohexane ಅಂತ ನೇಮಿಂಗ್. methyl cyclohexane. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಈಕ್ವಟೋರಿಯಲ್ ಪೊಸಿಷನ್ಗೆ ಆದರೆ ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ದಿಸ್ ಇಸ್ ದ axial position, this is the equatorial position. In that you have to know about that when we write the straight line straightly. ಓಕೆ, ಅಂತಂದರೆ ಸ್ಟ್ರೈಟಾಗಿ ಅಪ್ವರ್ಡ್ಸ್ ಆದರೂ ಆಗ್ಬೋದು ಅಥವಾ ಡೌನ್ವರ್ಡ್ಸ್ ಆದರೂ ಆಗ್ಬೋದು. ಈ ಥರ ಲೈನ್ ಬರೆದ್ರೆ ಅದು ಆಕ್ಸಿಯಲ್ ಆಗಿರುತ್ತೆ. ಈ ಥರ ಸ್ಲೈಟಾಗಿ ವಾರಡಿ ಆಗಿರುತ್ತಲ್ಲ ಅಂತಂದರೆ ಸ್ಲೈಟಾಗಿ ಡೌನ್ ಅಪ್ ಸೈಡ್ ತೋರಿಸಿರ್ಬೋದು ಅಥವಾ ಡೌನ್ ಸೈಡ್ ತೋರಿಸಿರ್ಬೋದು. ಅದನ್ನು ಈಕ್ವಟೋರಿಯಲ್ ಪೊಸಿಷನ್ ಅಂತ ಕರೀತಾರೆ. ದಿಸ್ ಈಸ್ ಆಲ್ ಅಬೌಟ್ ಈಕ್ವಟೋರಿಯಲ್ position. Okay, this is methyl group at equatorial position. Okay, ಇಲ್ಲಿ ಏನಾಗುತ್ತಪ್ಪ ಅಂತಂದರೆ in comparing to axial position and equatorial position, in the methyl group should be attached at equatorial position. This molecule is more stable compared to methyl group is attached to axial position. Okay, this is less stable and this is more stable. Why this molecule is less stable? Because when methyl group occupies an axial position, it suffers a steric crowding by the two axial hydrogen located on the same side of the ring. It means, for example, why when the methyl group is substituted at axial position, when is less stable, when the methyl group is occupies an axial position. Okay, axial position, it suffers steric crowding. Okay, steric crowding means large molecule should be present in the carbon atom. Here methyl group is compared to hydrogen, methyl group is heavy molecule, so it has a steric crowding. And another reason is also there, but why? By the two axial hydrogen located at same side. Okay, it means ಈಗ ಆಕ್ಸಿಯಲ್ ಪೊಸಿಷನಲ್ಲಿ CH3 ಗ್ರೂಪ್ ಇರುತ್ತೆ. ಆ CH3 ಗ್ರೂಪ್ ಇರೋ ಪಕ್ಕದಲ್ಲೇ ಎರಡು ಆಕ್ಸಿಯಲ್ ಪೊಸಿಷನ್ದು ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸು ಲೊಕೇಟ್ ಆಗುತ್ತೆ. ಸೊ ದಟ್ಸ್ ವೈ ಇಟ್ ಈಸ್ ಲೆಸ್ ಸ್ಟೇಬಲ್. ಓಕೆ, ಹಿಯರ್ ಯು ಹ್ಯಾವ್ ಟು ಸಿ ದ ಸ್ಟ್ರಕ್ಚರ್. Okay, in that, here this will be the CH3, this is C, this is bedadu. Okay, here in this position CH3 is substituted, H. Okay, this is the CH3 is present and this is the H. Okay, next this is 1 2 3 4 5 6. Here this will be the present, and this is also the presence of one of the hydrogen atom, and this is also the presence of one of the hydrogen atom in the axial position. This is the axial position. Okay, and this is also the axial position. This is 4. Okay, these two hydrogen atoms should be near to this CH3 group. Okay, these two axial position of hydrogen atom should be near to this two hydrogen atoms present in the CH3 group. So it is less stable, it suffers from the steric crowding. Okay, why? The methyl group substituted at the axial position is less stable because it suffers the steric crowding by the two axial hydrogen located at same side. Here this is the structure, this will be the located at same side, in between the CH3 group should be present. Okay, this is all about when methyl group is occupies at axial position. But here when methyl group is occupied at equatorial position is more stable. Why? They will ask in your exam, why the methyl position at methyl group at equatorial position should be substituted, why it is more stable. You have to give the reason. When methyl groups occupies the equatorial position, then it's free from any steric repulsion. Okay, steric repulsion or crowding, both are same, hence it is more stable compared to axial position, more stable. In the axial position there will be steric crowding in between the CH3 group and the two hydrogen atom present in the axial axial position, so it is less stable. But in the equatorial position there will be no steric crowding in between the equatorial position. Here this is the axial position and this is the CH3. Here there will be no presence of axial hydrogen near the CH3 group or equatorial hydrogen near the CH3 group, so that's why the steric hindrance should be less, so it is more stable compared to axial position. Okay, this is all about the monosubstituted cyclohexane. Monosubstituted means the substituent group can occupy either in the axial or a equatorial position. This is methyl group at axial position, this is methyl group at equatorial position. The name of this molecule is methyl cyclohexane. In equatorial there it is more stable, it is less stable. ಯಾಕಪ್ಪ ಅಂತಂದರೆ ಇದು ಸ್ಟೀರಿಕ್ ಹಿಂಡ್ರನ್ಸ್ ಇರುತ್ತೆ, ಇದರಲ್ಲಿ ಸ್ಟೀರಿಕ್ ಹಿಂಡ್ರನ್ಸ್ ಇರಲ್ಲ. ನೆಕ್ಸ್ಟ್ ಥಿಂಗ್ ಈಸ್ conformation of disubstituted cyclohexane. Okay, it means last theory will be monosubstituted cyclohexane. Okay, it means only one substituent group should be attached to cyclohexane, and here there are two substituent groups should be attached to cyclohexane. There are with respect to disubstituted. Here with respect to when two substituent group is attached, for example methyl group, with respect to disubstituted cyclohexane has 3 isomers are possible. Okay, here when the substituent group should be attached to cyclohexane, 3 isomers are possible. You have to see here, this is the cyclohexane. Okay, this is one substituted, this is another one, this is the 2 disubstituted methyl group. When we writing terminal ends, that should be called it as a methyl group. In your first PUC classes you have learnt a bond line structural formula. When terminal end is present, that is called it as a CH3 group. ಈ ಥರ ಗೀಟ್ ಎಳೆದು ಬೆನ್ಸಿನ್ ರಿಂಗ್ ಅಥವಾ ಸೈಕ್ಲೋಹೆಕ್ಸೇನ್ ರಿಂಗ್ಗೆ ಅಥವಾ ಬೆನ್ಸಿನ್ ರಿಂಗ್ಗೆ ಇಟ್ಟರೆ ಇದನ್ನು CH3 ಗ್ರೂಪ್ ಅಂತ ಕರೀತಾರೆ. ಗೊತ್ತಾಯ್ತಾ, ಇದನ್ನು CH3 ಗ್ರೂಪ್ ಅಂತ. ಸೊ it is the naming of this group is 1,2. Here give the number 1 2 3 4 5 6. Okay, 1 and 2. In the position of 1 and 2 the substituent group is substituted, so 1,2 dimethyl cyclohexane. Next another one is, this is the position 1 and this one. Okay, this is the position. Okay, this is also dimethyl cyclohexane. Then this is also the dimethyl cyclohexane. In that you have to know about that this is the para position, this is the ortho position, this is the meta position. We can also say that this is the ortho para dimethyl cyclohexane, also ortho para meta dimethyl cyclohexane, para dimethyl cyclohexane. In that the naming of this isomer is 1,3 dimethyl cyclohexane. Here 1 2 3, 4, 5, 6. Okay. Next here 1, 4 dimethyl cyclohexane. 1, 2, 3, 4, 5, 6, 1, 4 dimethyl cyclohexane. This is all about the disubstituted cyclohexane, and also depending on the orientation of the 2-methyl group, they have a conformation. It means 1, 2, this isomer has their own conformation, this isomer has their own conformation, and this isomer has their own conformation. I will explain you in the next class. Thank you.